Any questions?
So as I was doing this, I was looking at the textbook and it was talking about R. So is it just finding the hypotenuse first and then solving it from there?
So what was different from what we did? Was it something different then from what we just did?
Kind of. It explained this whole concept of like finding R, and the way you find R is taking a squared plus, like, it took the point and it made the x coordinate a and then the y coordinate b. It was saying you
But this
take
is what
a
is
squared.
given to us. I have no choice. I have to use this.
Okay.
I have to picture the point. And it's based on the coordinates. The x coordinate is -1/2. The y coordinate is this. So this is my point. So once I have the point, I form the right triangle, which is this is 1/2, and the height here is the square root of 3/2. I use the Pythagorean theorem because it's a right triangle. This is a right triangle. A leg squared plus the other leg squared equals the hypotenuse squared. So x squared equals 1. 4/4 is 1. I take the square root, I get plus or minus 1. So you are saying that there was something different done in the book, or?
Kind of. Or it looked different, but your way is easier.
Okay, I don't mind if you use other methods, it's fine too. So you're saying by R, you're talking about the radius.
Actually, no, it didn't say. Well, it didn't say R was equal to the radius. It said, actually, let me just look at it.
But I need the radius, no matter how you want to call it. You call it the hypotenuse, you call it the radius, it doesn't matter. In this case, I really didn't, because it was the unit circle. But it may or may not be the unit circle. So I have to determine it if I don't have it. It was redundant because we already know what angle this is. It's 60 degrees. If its sine is the square root of 3/2 and its cosine is 1/2, it has to be 60 degrees. So obviously this must be 1. But it's not always the case. Is this clear? Is this problem clear now?
Yeah.
Do we need other examples or other work or any other questions, anything else? Okay, so let's go back to the book. So we did, remind me please if we found any reference angles. We know how to find the reference angle, but do you want to choose an example with a reference angle?
Can you do 49?
Yes. Where is
Please.
49? Right here. 8 pi over 3. Good. So in 49, 8 pi over 3, we're only asked to find the reference angle. Good. So remember this, and you have to know by now that this is how many degrees? Good. 6 times 8. So we're talking about 480 degrees. A full or complete rotation is 360. So 360, and from 360 to 480, we have 120 degrees. So this is 180. I'm sorry, we said 120, so I went too far. So 180 to 120, so we're right here. I went too far. So that is 60 degrees away from 180. So we found the 8 pi over 3. Full, so 360 plus 90 plus 30, right? So the reference angle, can anyone tell us how big is the reference angle?
60.
Yes, 60 degrees or pi over 3. So that's how we find the reference angle. Okay? So find the exact value of each expression. So let's look at one of them, one from here and one from this set, and then we can move on. So let's choose one from 59 through 82. Find the exact value of each expression. And then one from 83, unless you need more, 83 through 100. Anyone?
We do 73.
Yeah, perfect. 73. Very good pick. So for 73, we have sine of -2 pi over 3. I was gonna talk about this situation anyway. It's a very good pick. Thank you so much. Okay. How many types of symmetry we know for functions? We discussed symmetry some time ago. How many types? And you know, 2 types. What are they? Please. Ethan, Blake, Axel, anyone, please. We've discussed this. It was part of our first test. How many types of symmetry?
Is reflection one of them?
Symmetry, not transformations. Symmetry.
X and Y axis or origin?
Yes, yes. So you're talking about odd and even.
Oh, okay.
Correct. Awesome. So odd is when it's symmetric with respect to the origin, and even symmetric with respect to the y-axis. Very good. And remember what happens for each. Anyone remembers the property for the odd and the property for the even? What is the property and the algebraic property that we check when a function is odd or even? We calculated
F of -x.
brilliant. Thank you so much for
Equal
both of
to
them. For both of them, good. In the odd situation, it was equal to,
F of x.
careful,
Oh,
F of X.
negative f of x. Good. So these were the 2 properties. If a function is symmetric and it's even, this has to happen. If a function is symmetric and it's if the function is symmetric and it's odd, this has to happen. If it's symmetric and it's even, this has to happen. Okay. Trig functions. I did not forget about the problem. Trig functions. All with sign are odd. All only with cosine are even. So everything is odd except cosine and secant. Everything is odd. If it has sine in it, like sine itself, tangent, cotangent, and a cosecant, they're all odd. The only ones that are even, cosine and secant. So cosine of negative alpha equals cosine alpha. Secant of negative alpha equals secant alpha. Everything else follows this. Sine of negative x is negative sine x. Tangent negative x is negative tangent x. And so on and so forth. I'm going to write them right now. not before I correct my infinity here. So everything else is odd. So sine negative alpha equals negative sine alpha. Tangent negative alpha, negative tangent alpha. Cotangent negative alpha equals negative cotangent alpha, and cosecant of negative alpha equals negative cosecant alpha. These are the only two that are even. Everything else is odd. Because sine is odd, and sine is in this function, tangent is odd. Because sine is in cotangent, cotangent is odd. Because sine is in cosecant, cosecant is odd. Finally, we go back to our problem. Since I know that sine is an odd function, I get rid of the sine, S-I-N-G, of course, the sign of sine immediately. I don't ever want to go, like I always tell you, you will never be able to force me to solve such an equation without eliminating the negative leading coefficient. I will never do it. I will always first multiply by -1 and then solve whatever. The same thing here. You will never, ever force me, because I will never accept it, to go around and worry about the negative angle. Absolutely not. I'm not lazy. I know what to do, but this is the easiest thing. And I always have to focus on a positive angle. The negative sign can wait patiently. Similarly to this, I refuse to solve an equation with a negative leading coefficient. Here, moving forward, I refuse to even talk about sine of a negative angle or a trig function of a negative angle when I have this property. They're all symmetric. I'm using their other odd or even. I will never go and position a negative angle. What's the point? So then I'm going to write it one more time from the beginning. 73 sine of -2 pi over 3. Sine is odd, negative sine 2 pi over 3. And I know what to do. I have to find the reference angle. 2 times 60 degrees. That's again the same angle we just discussed a minute ago. It's 120 degrees. So 2 pi over 3. This is in the second quadrant. This is the reference angle, the acute angle formed between the terminal side and the x-axis. Okay, so the answer will be negative because of this sign, but this number will be positive. So we are here. So the reference angle is pi over 3. This equals to sine pi over 3, which I know is the big angle. It's not 1/2, is the other number from the little table. If it's the small angle, sine pi over 6, I will write 1/2, but it's the big angle, it's the 60 degrees. So sine 60 degrees is the other number. It's not 1/2. And it's not the square root of 2 over 2 because it does not have 4 in the denominator. That's how we do it. I accept other methods, of course, but I think that this is the easiest. Okay, do we feel like looking at another example, or we move on to the last set here?
Can we do 68?
Where this one, 225, okay. So let's look at 68. Tangent of 225 degrees, okay. So tangent of 225, so let's see where 225 is. So this is 180 degrees, and I have to add 45 degrees to this. Excellent. Right in the middle, because 45 and 45 will be 90. So from here till here, I have my angle of 225 degrees. The terminal side is in the third quadrant. where in the third quadrant, tangent and cotangent are positive because both sine and cosine are negative. Both sine and cosine positive, both sine and cosine negative. That's where tangent and cotangent are positive. Same sign, positive, same sign, positive for tangent and cotangent. So then I find the reference angle, which is definitely 45 degrees. So therefore, I will write tangent 225 equals tangent 45 degrees. And I know this is the square root of 2 over 2. I should just, let me not write that there because it's too close to the circle. So it's the sine is the square root of 2 over 2. Cosine is the square root of 2 over 2. I wanted to show the ratio, but there is no need. They're the same. I will simply write 1, and it's done. Good. Other questions? Is this okay?